So what I would be probably presenting today is kind of be with OFDMA for some time. That's what I would say. Okay. So I have requested the Alethea team to do tests on OFDMA, how it is performing in real world. When I say real world, it is almost real world. Real world is probably not so easy. Okay. So it's a lot of hard work, and in the end, we are Wi-Fi test engineers, and any data thrown at us, there will be, I don't know, 100 or 1,000,000 questions. Okay, whether did you take care of this, did you take care of that, and stuff like that. It's tough, but with the results that I present, hopefully, we will find what is working and what is not working in the field with respect to OFDMA. What is the original motivation of OFDMA? I'm sure there are a lot of people in this room who are more qualified to talk about it, but I'll just simplify it for myself. So they said that this high density environment is coming soon, and all of us have to be prepared. There is some kind of consensus, I would say. There is a lot of inefficiency in the way Wi-Fi is currently working, and a lot of airtime is wasted. So there are simulations that say, I don't know, about 30% plus has gone on only people backing off or the clients backing off and just listening to the channel for no reason, and this kind of stuff. And this is what is supposed to be causing higher latencies and lower aggregate throughput overall. I think the motivation is very clear. We want it to work. We want the Wi-Fi to work in high density environment, which is coming, improve latency, and improve the aggregate throughput. So yeah, so high density environments, I put two examples. This is a football stadium, and somebody put a very innovative thing, what people are doing in the stadium. And there is this office, which is also, high density in enterprise level. So we'll come back to this slide in the end to see, how this is working. Just one slide. I really don't want to go through this. What has been done with the introduction of Wi-Fi 6 and OFDMA? We have these resource units with variable subcarriers. There will be a centrally controlled dynamic assignment from AP. UL and DL assignments will happen via some new PPDUs that are introduced. In general, just for the sake of our discussion, MU PPDU refers to the what the PPDUs that have been allocated for either uplink or downlink transmission via OFDMA. So there are some supporting types: trigger, BSR, BSRP. We really don't, because this is about experience in the field, so I really don't want to get into the details of any of this unless it is really needed. What they said also is that it is mandatory to support reception of MU PPDUs. So if, to put it the other way, if AP supports OFDMA, then everything should work. Clients will anyway mandatorily support. So yeah, there are stars to all this, but we'll come to it shortly. So we have tried to minimize the effort to get the test results. So in this case, we have used what Gagan has shown before as Lena. So this is the box that we call lab in a box. It has 12 Wi-Fi 6 clients, and we have put 2 of them and a test AP in the chamber, and we have done some tests, and we have changed the AP as well, to see how different APs are performing. When I said it won't be real world, a lot of us don't like iPerf 3 for real user experience, but I was forced to use for this, and but at least we are using Asterisk server to actually do real world SIP calls. So to that extent, it is real. So what do you get? What is it that we are trying to do? So we want to see how the allocation is happening in real world in that big RF chamber that I have shown. So for that, I need to analyze frames that are captured, again, using the same box. I mean, the box can be configured to have 6 clients in station mode and 6 clients in sniffer mode. So, you actually have all the packets analyzed. And finally, it will throw up some data like this. So you can get stats, UL OFDMA stats the way it is. You can get number of SU PPDUs, number of trigger data PDUs, null frames, trigger null frames, trigger block acts. Of importance, again, is HU MU PPDUs, and if you are doing uplink, it is the trigger data PDUs. And then, how the MCS varied, for different clients, and how is the RU allocation, what type of RUs got allocated to each of this. This is the kind of data that I would get, and then, probably we go further and see, what is the end result of it and how it aligns with the data that we have seen. Okay, so this is where the testing starts. So what did we do first? So we did SIP call test. So this is the closest you can do to a non-proprietary VoIP call. Okay, so we have an AP, and where we have a lever on switching on and off OFDMA, and this is how the results are. That if you look at it, 6 clients or 12 clients, there is obviously, if you look at latency, OFDMA has improved latency. It has become half. Jitter is also better. Loss, I really don't consider this too much here. And you see that even for 12 clients, it has reduced. What's happening on the allocation? It's not bad. Actually, there were 6 clients, but one of them, for some whatever reason, did not get any allocation. It is okay. I would not call it completely fair, but the wheel looks okay. As the number of clients increase, allocation looks far, far more fairer. And if you look at it, for my VoIP call or the SIP call, 83% of the frames were MU frames, which means that OFDMA is actually working. Okay, so that's about VoIP. The next thing of interest is throughput. So I don't like to throw throughput numbers on people, but this is what it is. So with OFDMA off, we have 507 Mbps aggregate for 12 clients, and with on, it is 423 Mbps. Latency, actually in parallel, we are running a ping to see what is the RTT. RTT is lower with OFDMA on. If I look at the MU frames with OFDMA on, the number of MU frames is actually 11%. So the AP is, what I see is that the AP is intelligent. It has gone the traditional way and tried to get it up. The number of MU frames, 11, means most of the time the scheduler is not switched on or is doing things normally. So if you see the wheel, it's all over the place. I don't want to read too much into this. So why, there can be a question on why I'm not talking about uplink allocation at all. All this is with respect to DL. We figured out very late in the test that Intel client does not support BSR, the buffer status report. So with it, more or less, Uplink OFDMA is killed for these clients. So the next one is uplink throughput results. Actually, I would say this is better. It is doing better than downlink. Let me go through it. So if you see, it's close. But you see that OFDMA off is still better. And I don't know if I don't want to read too much into this latency. I don't know, 20 milliseconds for a ping. I have no real, what I would say, input on this. But this still means that it is doing, the OFDMA on is not really giving any additional aggregate throughput. But of importance is that the total number of MU frames is 68%. So why is it, and I already mentioned that it is all DL OFDMA only because the Intel client doesn't support BSR. So which means the TCP ACKs, in this case because I'm doing a TCP test, are going via the MU frames. Okay, so my read of it, I suspect that this is why the performance is closer in terms of a total aggregate throughput. So 539 versus 635. Okay, so as an additional thing, I asked them to do 6 clients, DL throughput test and 6 clients UL throughput test. It did not throw up anything too different. But in this case, I guess because of the TCP ACKs going via OFDMA, UL is actually beating DL, but it seems to be also beating when OFDMA is off. So I don't have a logical conclusion from it. But if you look at the number of MU frames, it is matching with the previous standalone DL and UL throughput tests. Mixed traffic results. So this I would consider as the most important part of the whole thing. So 6 clients are doing VoIP calls and 6 clients you are just running some TCP traffic via iPerf3. So you see that with OFDMA on, those 6 clients actually performed better, which actually had VoIP calls going on. Okay, so latency is very, very low. So what this means is that we have this WMM classes, all these QoS things that are supposed to provide that additional benefit for a VoIP or a video call. It seems to be happening automatically with OFDMA. The 6 clients otherwise would have suffered a latency of 124 milliseconds with OFDMA off, and they're better off with 30 milliseconds with OFDMA on. But then the scale is lower. It comes with a cost on the aggregate throughput, at least at this point of time in the AP that we have been testing. So this, I would say, is the key takeaway of how OFDMA is working in the field. I would love to do this test probably for, I don't know, 50 clients doing something like TCP and 50 clients doing a video or a VoIP call. But till we get there, this is the conclusion. So because we would want to check across other APs, so we have done tests with APs. So only one of the AP, I really have the control to switch on and off. Others are commercial. Some of them probably have some command line option, which we are not, we don't have access to. So if you see, the story is still same. With OFDMA off, the latency is higher, and different APs performing close. One AP is standing out for some reason. For the same AP, I have a result of throughput. So throughput seems to be suffering for this AP when I do the throughput test with OFDMA on. So this clearly says that at least for VoIP, the improvement holds good across most of the vendors. So this is the throughput comparison test for all the APs. So you see that OFDMA off is performing almost the best, but there is one enterprise AP here, which is actually doing good. I don't have a result for this AP with OFDMA off, but maybe they have some secret sauce here. This AP, which was doing very well in latency, is not doing so great here. There is one more AP which is still doing worse. So all this is done in the same chamber in a similar way, on things that we can control from the UI or what is provided. So this is just a comparison. So it seems that most vendors have implemented OFDMA and it is on, and it is working in some cases, and there is surely a latency improvement, either with clients doing separately a separate kind of traffic, or I don't know, for small scale of clients, it seems to be working, but I don't have data for a large scale. When I compared the data for VoIP 6 and 12 clients, the latency was actually increasing. So I don't know if I make the number of clients from 12 to, I don't know, 50, you know, what will the latency become? But it is to be seen. So coming back, so summary, this is what I think. UL OFDMA is broken if BSR is not supported by clients. So we also found a client which supports BSR. I don't have test results for it. DL OFDMA works for small number of clients and lesser amount of data. Latency decreases in mixed traffic at the cost of aggregate throughput. I think that there is still better efficiency with AMPDU, AMSDU at full buffer. That's why the aggregate throughput for OFDMA off is really high. I don't know, do we really want 500 clients with low latency VoIP traffic? Yeah, maybe in such a case would be really interesting to check with current implementation. So coming back to my earlier slide, so I think motivation for OFDMA was correct, but what currently we see in the field is that, you know, lower latency is achieved with some caveats, but higher aggregate throughput, I think, is still pending.
Hi. So what were the packet sizes in IBOF 3 test?
It's a default size that will become, I think, 1445 bytes in total.
When you do a testing for the Wi-Fi,
yes,
the main piece of the cake is that how the roaming part is being taken care on your testing.
How the roaming part?
Wi-Fi roaming.
No, see, this test is static, so I have put the clients in a big chamber and they are only still. So there is no roaming involved.
So the question, the test setup that you showed, does it test single APs only or multiple APs also?
I mean, it's a chamber in which we put AP in one side and we put all those 12 clients on the other side. You can put multiple AP, but the test is done with a single AP at a time.
So sometimes what happens is that with a single AP, you get certain kind of test results.
Right.
But then in a practical deployment, because you have many access points,
right,
there are things like co-channel interference, etc.
Right. So, actually, ideally, I would like to do it in, you know, in a normal environment where there is interference and then give you results. But, you know, test engineers will have so many questions. So why is my throughput high? Why is my throughput low? I'm sure a lot of guys probably won't agree that, you know, 6 client or 12 client throughput is 600 Mbps for a 160 megahertz 2x2 set of clients. So to limit this boundary of my test is why I selected one AP and a chamber. Simplicity.
Yeah, can you please go to your slides, go to some result actually, go back. Somewhere you are showing that your MU packet percentage is more, but less, but throughput is kind of degrading. That the slides I want to see.
See, MU frames 68%.
Yeah, this is fair. I think MU percent is fair enough. So, but some slide I saw actually where MU percentage is very less, but still your throughput is 11% something it was there.
This one? Okay. DL, yeah.
Yeah, correct. This
yeah.
one. Why there is only here MU is 11%, but your throughput is down by around 100? Why so in this scenario?
Okay, so this is how the scheduler is working. What I am trying to tell from
then
this
it's not working actually.
Yeah, that's what is the conclusion from my last slide, right? Aggregate throughput, we have not found improvement with OFDMA on. Latency improvement, I can see in a limited way.
But again, it is a contradictory. If latency is improving, then your MU percent should be more. MU percent is very less, and you are seeing your latency increasing. Means latency improvement is there. How come it is possible?
So, I did not write any scheduler, but I think that it is the scheduler is written taking into account some packet sizes and how they arrive at the queue. I think, this is again just my opinion, that in such cases they are able to actually schedule them properly and get that required low latency. When the buffer is full and there is enough data to send, okay, I think it is either off or it is very inefficient.
So this latency is taken from ping?
This is from ping. So whatever test is done, I put it in the first line. So this is from ping. This is
And the traffic is running with the default payload?
yes.
Okay. Do we have result for kind of 64 bytes or 128 or 256 like?
I have it, but I don't have it as a slide, but I have it. It will be far lower. It will be some 10 times lower.
Maybe they can come to your booth. You can show them.
For sure.
Please visit their booth.
No, I have a different opinion. Maybe that will give you some kind of gain rather than looking at default packets.
I thought so and asked them to do the test. It was not. So
Yeah, so let me also add, because I thought I will get more questions in the morning. Sorry to jump, but I knew Rama's results. Other results from other vendors, other than Alethea, there is nothing consistent with what we have expected. And I can say it's wide across the industry. That's why I put in the remark earlier in my presentation that nobody has come with a very clear-cut case in a very neutral environment with sort of interoperable case.
So I just want to share our data from XLinear.
Can we just 1 minute, sorry, in the interest of time, I would like to kind of see if there are other questions, and then maybe we'll come back to you. Just give us a couple of minutes.
discuss
Thank you.
for sure. Yeah.
I just want to understand whether it was taken with MU-MIMO disabled and also OFDMA parameters were forced.
No, we did not change the, except that AP where I can switch off and on, everything is default.
Case IPERF, okay, default we don't know if MU-MIMO was enabled or disabled.
Actually, I don't want to get into those kind of things. Then, then I have another axis of test, MU-MIMO on, off. Then, we have more data and then,
So I think the comparison Rama showed was, except for one AP, all the other APs were like black box, which you didn't control much in terms of OFDMA.
Yes.
So we should assume default there is something on.
it's
something
on. I think it is on. I mean, the scheduler is on. Whether they do it every time or not,
So I think one last question we can take, if that's there. If not, then we have a short video, Alethea being the sponsor also get to share some information. So I'll play the video. On behalf of Alethea, thanks Rama and Gagan.